Hi, this is Ahed from Logos Learning, and in today's video, which is Solving Exponential Equations Part 2, I will explain how to use exponential equations in the half-life applications. So let's attempt this question. The half-life of ruthenium-106 is 1 year, so the decay of ruthenium-106 is described by the exponential equation. Al, which is the amount left, is equal to Ao, the amount original, so the original amount, 1/2 to the power of t, where t is a time elapsed in years. If an original sample of ruthenium-106 has a mass of 128 milligrams, and there are 2 milligrams left, what is the time elapsed? So we're looking for t. What information do we have? We know that, as the question is saying, the amount original is 128 milligrams. 128 milligrams, and the amount left is 2 milligrams. So we have 3 variables here. We know these two, and we can solve for the third. So let's plug into the equation. The amount left is 2, which is equal to the amount original, which is 128, times 1/2 to the power of t. So whenever you want to solve for a variable, you have to isolate it. Let's start dropping things from this side so that we can isolate t. Let's drop the 128. So we have to divide both sides by 128 in order to get rid of the 128. So this cancels out, and we're left with 2 over 128, which is 1 over 28 divided by 2 is 64. And we have on this side 1/2 to the power of t. Now, how do we convert 64 or 1 over 64 to the same base here? We have here the base is 1 over 2, here the base is 1 over 64. So how do we get rid of that? 1 over 64 is basically 1 over 2 to the power of 6. Okay, 2 times 2 times 2 times 2 times 2 times 2 is equal to 64. So 1 over 64 is equal to 1/2 to the power of t. Now here, the base is 1 over 2 to the 6. How do we make it just 1 over 2? Well, 1 to the power of 6 is equal to 1. So we can give 1, the numerator, a power of 6. 2 to the power of 6 is equal to 1/2 to the power of t. Let's continue on this side. So 1 to the power of 6 over 2 to the power of 6 is same as saying 1/2 to the power of 6. This is using the division rule. I'm going to write the rule on the side here. A over b to the power of m is equal to a to the m over b to the m. So all I did here is I went in the reverse way. I had a to the m over b to the m, and I put it in this form. Let's go back to black. 1/2 to the power of 6 is equal to 1/2 to the power of t. Now we have the same base, which means that we can equal the exponents. 6 is equal to t. So in 6 years, if you had 128 milligrams of ruthenium-106, you will have 2 milligrams left. Now, if you see my other video, my older video, you'll see that I explain how to solve exponential equations, and if you'd like to see some more examples being solved, keep watching the video. If you're done with this and these are easy for you, then just you can watch my next video. So 2 to the power of 6, or 2 to the x, is equal to 16. We want the same base. 16 is the power of 2. It is 2 to the 4, so we're going to convert that. 2 to the x is equal to 2 to the 4, which means now that the bases are equal, x is equal to 4. Next one, negative 3 to the power of x is equal to negative 27. How do we convert negative 27 to the same base as negative 3? Well, negative 27 is negative 3 cubed. Now that the bases are equal, we can equal the exponents. X is equal to positive 3. Next, negative 1 to the power of m is equal to negative 1. Well, we know that every number is to the power of 1, so negative 1 to the power of 1 is negative 1. Here we have the same bases, which means m is equal to 1. We're going to keep going. Negative 1 to the power of x is equal to negative 1. How do we make these two bases identical? Well, we know that any number to the power of 0 is equal to 1. So, assuming here that the base was negative 1, if we had it to the power of 0, it will be equal to 1. So here, whenever you have 1 and you have a different base here, you can put whatever number you want here to the power of 0. So now that the bases are equal, x is equal to 0. 7 to the w minus 2 is equal to 49. 49 is the power of 7, so we're going to convert it to a power of 7. 49 is 7 squared. Now that we have the same base, we can equal the exponents. W minus 2 is equal to 2. W is equal to 2 plus 2. W is equal to 4. Same thing here. 3 to the x plus 4. 27 is the power of 3, is 3 cubed. Now that the bases are identical, we can equal the exponents. X plus 4 is equal to 3. X is equal to 3 minus 4. X is equal to negative 1. Oh, all gone. Oh, it's back there. Now let's keep going. Here again we have a base of 1, which means we can change it to base 3 to the power of 0 to equal the bases. 3 to the power of 2 minus 2x is equal to 3 to the power of 0, which is 1. Now that the bases are identical, we can equal the exponents. Now I like my exponent or my x's to be positive, so 2x, I brought it over, is equal to 2 minus 1, brought the 1 over. So this is 1 is equal to 2x, divide both sides by 2, x is equal to 1 over 2, 1/2. Let's keep going. 4 and 2 are the bases here. Well, we know that 4 is the power of 2, so we're going to convert 4 to 2 squared to the power of 4x minus 7 is equal to 2 to the power of 2x plus 1. Now that the bases are equal, we can work with the exponents. 2 times 4x minus 7 is equal to 2x plus 1. So this is 8x minus 14 is equal to 2x plus 1. All I did here is I multiplied the 2 into the bracket. So 8x minus 2x, 6x is equal to 1 plus 14, 15. And we have x is equal to 15 over 6. Let's keep going. Uh, 5 to the power of x minus 4 to equal to 1 over 5. So here we're going to convert the 1 over 5 to the power of 5, or to the base of 5. 1 over 5 is equivalent to 5 to the negative 1, so we can change it that way, is equal to 5 to the power of 4 minus x. We can get rid of the bases now, since we have identical bases, so 4 minus x is equal to negative 1. 4 plus 1, 5 is equal to x. Let's keep going. It gets a little bit more interesting and more fun. So let's say we have 10 to the power of y minus 2 is equal to 1 over 10,000. So we know 10,000 is the power of 10. Let's just change that first. 10 to the power, okay, what's going on here? 10 to the power of y minus 2 is equal to 1 over, this is 10, and you can count the zeros. You have 1, 2, 3, 4, 4 zeros. Now, we want the base to be in the numerator, which means we can bring it up by changing the sign of the exponent. So 10 to the power of y minus 2 is equal to 10 to the negative 4. Now that the bases are identical, we can y minus y technology. So y minus 2 is equal to minus 4. Y is equal to minus 4 plus 2, just 2. Now this is an interesting one. Here we have a common factor that we can take out. Let's convert 2 to the power of 2 plus x to 2 to the power of 2 times 2 to the power of x. And this is correct since a to the power of m times a to the power of n is equal to a to the power of m plus n. So whenever you see that the exponent has two added terms, you can change it in this way to make things clear. We're going to keep going. So here, if you look at this, you have two terms, and both terms have 2 to the power of x in common. So we're going to take that out as a common factor. So in the first term, if we take out 2 to the power x, we have 2 squared left. And here, if we take out 2 to the power x, we have just 1 left, is equal to 48. Now, let's work on the brackets. 2 squared is 4, minus 1 is 3, is equal to 48. Now let's divide both sides by 3 to isolate for the x. So this cancels out. 48 divided by 3 is equal to 16. So 2 to the power of x is equal to 16. 16 is the power of 2. 2 to the power of x is equal to 2 to the power of 4, which is 16. Now that the bases are identical, we can get rid of the bases and work on the exponents. X is equal to 4. So I hope that this video was helpful, and if it was, please give it a like, and you can subscribe to my channel. Have a nice day. Bye!